Good morning. I'm Bruce Lindsay. I am the program chair for Technical Committee 6.9 Thermal Storage. TC69 is sponsoring this session. The session is entitled New Entrants to the Thermal Storage Market to Utilize Investment Tax Credits. Hopefully all of you are aware that the Inflation Reduction Act of 2022 extended the tax credits for wind, solar, geothermal, and added tax credits for energy storage, both electric batteries and thermal batteries. In addition, they gave bonuses if it was made in America and additional bonuses if it was located in an energy community. Well, that changed in 2025 when we passed the One Big Beautiful Bill. All the solar credits, all the wind credits, all the and some of the electric battery credits vaporized. Remaining are the tax credits for geothermal and thermal energy storage. So we're pretty excited about that. That's a real big game changer, okay? And what that's doing is it's bringing in a lot of new firms with what I call specialty or different types of energy storage. And TC69 wants to showcase some of these, but we want to make sure it's not commercial, okay? This is not show and tell, here's my product. They've got some really neat solutions to projects. So let me stop there and introduce our first speaker. And that's, one of the things also, I keep the bios short. I'm basically name and company. And if you have interest, you can go in on your app and you can get the bio there. And you can go a step further. I think in the directory, they actually have the LinkedIn link. So if you have any interest, it's there for you. And hopefully that way I won't bore you to tears with a long intro. So our first speaker is Mr. Garth Schultz. He's president of Thermal Energy HQ. I'm not going to say anything more than that. Other than that, I would like to welcome him. Garth.
Good afternoon. Thank you, Bruce. My venture into thermal energy storage has a past in photovoltaic thermal collection. That's what I started out in late 2006 and dreamt of a product to do photovoltaic and thermal capture in a module. And over the years, as we developed this product out, it came to bear that when you're putting up solar thermal collectors and where we had envisioned a man-portable module, we had to put very easy, robust energy storage underneath of it in order to collect hot water that's produced by the PVT system. And in the course of our development, putting out installations, modules, and then would come a rack and then the tank that would be underneath of it. And then our design motivation was to produce a module tank that could be inside, outside. We've even buried them at grade and became very flexible. In our experience in the past 3-4 years, we put an installation out at a site in the Caribbean that had a derelict hot water system in it. Immersive hot water heaters, steel tanks. It was a mess. And along with the PVT system, what we put underneath that assembly to service it out, we did an air source heat pump and a couple of storage tanks, so they had a baseline system to react to and to supply hot water into their facility. And it was with that notion of, I think that there's a bigger market here for the air source heat pump and the tanks that we have in place in order to make a shift into the market. And certainly, as Bruce pointed out, when the One Big Beautiful Bill came out, the idea of PVT and what we looked at for tax incentives and credits, we really shifted over to the energy storage. And with that, we'll see what we're up to in terms of our presentation. Objectives, benefits to the utility, to provide district cooling to their customers utilizing thermal energy storage to shift off-peak electrical load. None of this learning objectives, they added this slide into me, so I think that they're slightly different and will go down. I think they're meant for someone else. But outline what we've done in the past few years is one, with that base installation that we had done in the Caribbean, said, what can we do in order to provide domestic hot water utilizing our energy storage tank? And so using air source heat pumps and immersive heat exchangers, some unique for RO water where it's not treated, all plastic polymeric, and or corrugated stainless steel loop heat exchangers, or pumped suction tube and diffuser assemblies. We've put up several installations around the country. And in this outline, we're looking at the tax credits that will end up supporting those installations. So as that little graphic and video shows, the motivation of our tank is that it's all man-portable. No matter where you're at, you can walk the components into our tank and get them easily installed into a facility. The graphic on the bottom from left to right is the assembly sequence by which we can use an outer hoop, common TPO roofing membrane assembly or material, expanded polypropylene insulated sections that go in line, and then a high temperature PVC liner in order to contain the fluid. So our storage tank is unpressurized, and it's 100% polymeric and engineered foam construction. My background, I was an automotive engineer for 25 years, so I was exposed to the material set, the expanded polypropylene foam that we use as the main insulator section. And then that is what the IP of the tank is about, is how these parts knit together. One, to give you great thermal retention, and then also to make sure that it is easy to manufacture. And one, if you speak to the material sets that we use, expanded polypropylene foams and all that, it's 100% reclaimable. So as a recycling motive at the end of its life, you can move it out and it doesn't become a landfill. It can all be recycled. And as stated, we're patented, made in the USA, so that we get that extra 10% that you're going to look at on the financing side for a production bonus. For us, as a manufacturer, and we're based in just outside of Detroit, Michigan, is that we qualify for the 45X manufacturing credit. And our material base, it is all around the Great Lakes where we obtain our materials. Our liner supplier is up in Traverse City, Michigan. EPP, we have produced from a great international supplier, and then TPO roofing membrane that we use, we have several suppliers that are domestic for that component. And those are the three major things that we do into supplying equipment and materials into the product. So with it assembled, it says it's a high-performance thermal battery as it's been defined and as we go and reach out to find markets. Long service life, plastic foam can be anywhere. The outer TPO roofing membrane, that's a good material selection because it can be out in the environment for 30 years as it's already qualified for for those kind of environments. The tank itself, we've gone through and we've done UL qualification on it, so the materials, and it's a listed tank that you'd find under alternative energy storage. So if that's a requirement as you go out and do your installations in the field, you can tick the box and say, yeah, they got a UL qualified component. And as an item that we see to deploy out in larger volumes, that all these parts, because they break apart, they can all nest together, and we can fit a multitude of tanks that otherwise, if they were unitary construction tanks, we outstrip that by a factor of 5 or 6 to 1 in terms of being able to haul it to site. Once again, nesting that reduces carbon footprint because you're only doing one haul and you're not hauling air. So the investment tax credit for us was actually, quite good for us. So and it comes down to where we've looked at an Inflation Reduction Act, and then also when the coming on of the One Big Beautiful Bill says, as someone looking to finance a project, we get the 30%, and then as a domestic content, they get another 10% kicker onto that. And like I said, as a manufacturer, we're at 45X. Input into what we take away. And then you name the type of appliance that you want to include in your setup. So commonly we're air source heat pumps, but we also, obviously I got my start in PVT, solar thermal, that you can connect the tanks to. And then also if you have other energy capture mechanism, the superheaters, partial heat recovery systems, we can play with those ones as well. So a typical ITC credit that we look, and this example is out in California, is that doing the loads analysis, we can provide a system with a couple air source heat pumps, one 700-gallon tank, and then a bespoke pump group and diffuser and suction tube module that installs for $70,000. Federal ITC, 40%. Net project cost 43, and then we're competing against natural gas versus electric. So you do the math behind dividing the COP into the electricity cost, and then it outstrips the cost for the arbitrage becomes 6 cents positive. And so that's a good thing for us. Then along with that, that results in a low payback period for the system installed. And then with this installation in California, beyond the tank, so you can think of our tank and you can think of a crowded mechanical room. So when you go into that space, it's just like, where am I going to put energy storage and how am I going to integrate this system together? So working with a partner group out in California and in close contact with our client and customer, we said what we want to put in there is an all-in-one system. So not only the tank enables the installation to happen in 20% less time than it was if the plumbers and installers were crawling around trying to find places to put components. We provide the diffuser and suction tubes. We provide the seismic restraints. And on the front is a pump group and control system that manages that you give inputs for your cold water feed, your recirculation lines go in there, and then the IOs into the tank to withdraw the working fluid to put through a flat plate heat exchanger to extract heated assemblies. And then on the other side to interface with the domestic, with the air source heat pumps that are connected into the system, it manages all those activities. And all of this remains in a small little compact footprint. Aside from bringing the air source heat pumps to the system, you have great authority in order to do your installations at site. And with that, it's a lower cost, not only from a transaction business side for the client purchasing that, but also from the installation side. And on repeated installs, in which we put 15 out into service in that area, it shortens that time period enormously because they have one plumbing crew that's trained up, and so when they come to the next site, they say, it's the same thing that I saw at the last site. Did I miss a slide? Oh yeah, there's one. Another one that, a curious business case that we're looking at in Florida is that there's pockets in Florida where propane is very expensive, $3.50, almost $4 per gallon. Usually you see $1.20, $1.30 a gallon, but it's within that pocket that we came across this opportunity at a restaurant. And so they had an incumbent instant-on hot water heater from propane, couldn't get enough service out of it. So looking at the financial metrics here, 1,600 gallons a day, a high incumbent fossil fuel cost, we went and proposed our solution. We had one 6-ton heat pump and our thermal storage tank applied to it. You can see the hurricane restraints, so we're designed into that environment so that we can put tanks outside in a Florida environment. And that complete installation, took probably about a day, and a lot of it was training. So we brought in people, the contractor, the client, and then put that installation up. And it's highly effective. So annual savings over $9,000, and this single tank and heat pump installed for a little under $40,000. And so with the equipment and the incentives that are applied to that, it says you have, again, another short payback that's available to them, and then also reducing the carbon impact is that we've done a significant amount of work in that situation. Last one we'll look at, because it's on everyone's mind, is the Local Law 97 in New York. Everyone wants to go and look and do something there, and I know we've been putting our fingers into there, meeting with contractors, building owners, energy efficiency managers, wondering is, what is it that we can do to be effective in there? And I think it comes down, good first step for these guys when they ratchet into their emissions reduction in 2030 to 2034 is domestic hot water. It's a very safe approach, and so with this one existing property that we looked at, 180 apartments, the existing system fired on oil. That was relatively expensive in consideration of the electricity available and the arbitrage that we can go and provide by decarbonizing that situation. Financial impact is that they save their money. They have that 40% ITC, and the economics say it's its installed cost that 231 is reduced to $139,000, and so it's less than a 3-year payback. And the environmental impact for that is it's 88 tons of carbon saved every year. So we look forward to doing those levels of installations where we can make sense. Domestic hot water, safe, easy first step. The product plans for us is once again to step out into demand and load shifting, which is what which you can do if you've got large thermal storage and if you've got energy capacity and if you have an appetite where off-peak at night, time of use says, I got very, very cheap energy, let's charge the batteries. That's something that we all know, and I've seen at this conference and drilled into us over the past several days. So we store that energy and then we can dispatch it as required. Same go with peak demand. Same operation there. If you got a thermal tank that has capacity, can be easily moved in, easily sited, this becomes a reality by which people struggle with, especially if you're in the New York environment. Local Law 97, or the New York Fire Marshal says there's no lithium in these old buildings, so you have to come up with a plan by which you're going to do your energy banking. And for us, it's just sensible hot and cold water. So in summary, we've developed a modular thermal battery. But in addition to we see that as the enablers, so you can move this tank into a tight, crowded, mechanical room or space. Then add in the necessary infrastructure and components on the front side of it, and use all the materials around it, so you can have one complete module by which the client, the plumber, they're bringing their air source heat pump or whatever their generation source is, and then we can handle and manage, that fluid volume from there in order to provide great domestic hot water out into the field. That's my presentation.
Please come down and get a question. State your name and your affiliation.
Hi, my name is Khalid from Energy Management Consulting Group. I have a technical question, not about the incentive, but rather regarding the performance of the thermal tank. What is the maximum temperature that the tank can hold, and what is the temperature degradation over the course of the year?
Very good question. So maximum tank material ratings into that, we're at 200 degrees Fahrenheit, and then in terms of thermal loss per day, the 350-gallon tank that we have, the smaller one that we started out with, it's 2 degrees C per day in a free convection environment. So very low losses. Our trick into any of this is, yeah, the tank is knitted together and all the parts to fit together really nice, but what it is that in the I/O, the tubes and the things that you're putting out there, we avoid metals so that they don't act like wicks and antennas, and we typically use CPVC or other polymeric components to move fluid in and out for low energy loss.
Ed from Gutowski Engineering. You kind of implied this, but I think you're using a fluid there, sort of like a boiler water to a heat exchanger. Did I understand that correct? So heat pump to a fluid, and then a heat exchanger to whatever domestic hot water, heat, or space heating. Is that what I understood?
In the air source heat pump, it simply pulls out of the tank, which is the fluid volume, which is our energy storage volumes, goes through the air source heat pump and dumps it back into the tank. So the water, we have one working fluid, water, in the tank. And then your processed waters that you want to take out, we use immersive heat exchanger technology. We have a polymeric design. We also have standard, corrugated stainless steel loop technology that we put in there. And then on the more advanced one that we looked in at the last segment was suction tubes and diffuser plates. So a suction tube down at the bottom, and to maintain stratification and great energy availability is that you want to very gently take the fluid out, and then when it's heated up, very gently put it back in through a diffuser plate so you can maintain stratification. So we have three kind of technologies you can bring to present to move fluid in and out.
Aaron Farah from Purdue University. Also kind of for integrating your air source heat pump into that water loop, what's the maximum temperature that you can get from that air source heat pump to dump into that water tank?
Typical R32 is 60 degrees Celsius. So that's the we play to the hand that's given in terms of the air source heat pumps that are specified, and as I would imagine, as the CO2 ones come to bear, they're more along 70 degrees centigrade. So whatever you want to bring to the party in terms of your generation source will suit to manage.
Cool, thank you.
Yeah. Thank you.